Welcome to 18th lecture. We are studying electronic devices and circuits. Today we'll study AC analysis of emitter followed configuration. This configuration is also called common collector configuration because the collector terminal is common, it's directly connected to the supply. The input is applied to base and the output is collected from emitter terminal. Here is the schematic of this circuit where we have this input supplied at base through coupling capacitor C in, and the output is taken from the emitter through coupling capacitor C out. To perform DC analysis of this circuit, we assume this as the input loop and this as the output loop and can compute IP, IC, IE, BCE, bias point, etc. Here is the AC model of this circuit. For the supply voltage, this capacitor seems to be short circuit, and at this point we see two resistors to ground. One of them is RP. We have already studied that when we apply AC analysis, we replace DC source with its internal resistance, which is short circuit. So it is short circuited, it becomes ground because at the start of the source is ground. So RP to ground, and then we have the small junction resistance small re seen on the base side is multiplied with beta, and then at emitter side we have two parallel resistors connected to ground. So here we have drawn these two parallel resistors. When seen on the input side, they will be multiplied with beta. And on the output side, they won't be. And then this is collector terminal. From collector to emitter, we have a current source beta IP, and the collector terminal is directly connected to ground. And here it is. This is the equivalent circuit for emitter follow configuration. In this lecture, we will derive expressions for Z in and Z out of this configuration. So let's start with the input impedance Zi. To compute Zi, we have to remove this source, put an arrow here, at a Zi here, and then see all the paths to ground. Here is RP, it appears to be in parallel with this. So if we draw its equivalent again, it will be like this. We'll see an RP in parallel with beta RE, which is at this point divides, at this point is connected to the parallel combination of RE and RL. And since they are being seen at the input side, they will be multiplied with a beta. Then the lower sides, all these transistors RP, RE, and RL are connected together. So this is the circuit. This is the combination of resistors which we have to solve in series and parallel to find Ci. So starting from this end, beta RE in parallel with beta RL, the parallel combination of these two appears to be in series with this beta RE, and this whole is then in parallel with RP. How would you write it? Beta RE is RP. Ci is RP in parallel with what? parallel combination in series with beta RE plus beta times RE, beta times RE is in parallel with beta times RL. So this is the input impedance for this circuit. Involves these two resistors, the parallel combination. The parallel combination appears to be in series with this, and this whole is in parallel with this RP. And then we can compute C out. To compute C out, we look at here from the output side in, because we have to compute output voltage across RL. So you'll see inward from this side. We see RL and RE in parallel with each other. What else do we see? The upper side of these two is connected with beta RE. Since we are looking from the output side, the emitter side, this beta RE would be divided by beta and will become RE. And since RV is also an input resistor, when it's connected to RV here, we see from the inputs from the output side, it would be divided by beta. Here we have the C out, RE in parallel with RL. The top end of the two is connected to beta RE, which when seen on the output side is divided by beta, and then it's connected with RP, which when seen on the output side is divided by beta, and that's all. And then we have to compute C out, which is simple. It's RL in parallel with RE, RL in parallel with RE is in series with what? The parallel combination of the two is in series with RE plus this. There's one mistake here. This terminal can also be the same node, can also be considered connected here. So these three appear to be in parallel with each other. Plus sign, parallel sign here, instead of an addition, because these three are in parallel. RL, RE, and this series combination, they appear to be in parallel with each other. So RL in parallel with RE in parallel with this series combination. In the next lecture, we will derive expressions for voltage gain for this emitter follow or common collector configuration.